back with another episode of Leetcoding until I'm a Leetcode god. Eating some cinnamon raisin toast. Probably only gonna do a few problems. I've realized that I need to lower the amount of problems or the amount of time that I spend doing Leetcode so that I can focus on other things. I recently finished presenting my thesis about like a week ago, and I want to there's a few things I need to do with that. I need to revise it a little bit because I managed to pass, but they did want me to revise a few sections of my thesis. I pretty much just had to add 2 paragraphs in. One paragraph in the conclusion, and then another paragraph in the introduction. After I do that, I'm in the process of learning React. Because I do want to get good at React. I've been applying to more software engineering roles rather than machine learning roles. The first couple of months of the year, I was applying solely to ML roles, data science roles, but I don't know what it is with the job market, bro. I managed to land a few interviews. I think all the interviews I've landed have been for ML roles. I guess I landed one for a software engineering role that got they went into a hiring freeze. But I think it makes more sense to go for software engineering roles because ML just they want a PhD, bro. If you're not in a PhD program, a lot of times they're not even gonna look at you. I think I can still manage to get into data science, like machine learning role in the future. I think it would just require me to submit a lot of the research I do to like more prestigious conferences. And then over time, I think I can transition. But short term, I think I should focus mainly on software engineering roles. So that's why I want to learn React, because I don't really know. I only really know Python. That's the only language I've been using for years. I did know Java at one point. That was the first language I learned, but never learned. I stopped working in Java a while ago. So I want to get good with React. Like I think JavaScript's just a good language to have because you can build a lot of applications with it. Yeah, so I want to make my portfolio website using React 3 Fiber, or React and then 3 Fiber. I also want to put all of like the work I've done on my thesis on that portfolio website. And then like a few of the other projects I've done, maybe stuff that I'm working on, have links to like GitHub and everything on there. Just it makes it easier to document everything. And then yeah. I think that makes the most sense. In terms of other projects I want to work on, I want to make like a Spotify sort of bot. I actually wanted to make a bot for like Letterbox that could track, people's top 5 most watched videos or movies for like a specific community. But Letterboxd's API isn't public, so I'm probably gonna have to do the same thing just for Spotify in terms of like make like a Spotify Wrapped for yeah, just any time of the year. But I don't know. Hopefully I can use React for that too. Anyway, getting back into Leetcode, let's do that. Bro, my camera so dirty. It was so dirty. There we go. It's a little better. I wanted to get a haircut today, but there were no times available. I'm on graphs right now. It's weird. I think that, honestly, right? Me being completely honest, I think that graphs, honestly, are easier than some of the backtracking problems. I don't know. Like, logically, like, they might require more code to write some of, like, the graph solutions, but I feel like the logic makes more sense. Where I'm like, okay, if I was given this problem, I could just go through everything logically, go through the steps, and I would reach the conclusion. For some of the backtracking problems, I feel like I'm leaning more towards like I might have to just kind of do these problems over and over again until I memorize certain ways of doing different things. I don't think backtracking is too bad either. What else? I'm just going through each section. Once I get through graphs, honestly, I'll feel like I'll be pretty good. I'll be pretty set. I'm gonna go through, 1D DP, 2D DP, and then all like the smaller section like bit manipulation and all that. Just because intervals. Greedy is a section I think I need to go over multiple times because I feel like there's no pattern here, honestly. A lot of these patterns, I feel like you just have to know. You just have to have seen the questions before. I don't think for a lot of these questions I would have reached a conclusion. Advanced graphs, oh my god. This will probably be the last, will it be the last section I do? I don't know. I'm gonna go to, after I finish graphs, I'm gonna go to 1D dynamic programming, 2D dynamic programming. Then I'll probably go through bit manipulation quickly, math geometry. I don't really want to spend the most time doing topics that I don't think are asked a lot. So like, I don't think bit manipulation is asked a lot. Same thing with math and geometry questions. So I'm gonna do these two. Maybe then I'll do this. I don't know. Anyway, let's just do this. I'm going over. I did do all in gates. Right? I did that yesterday. Yeah. I did these two questions yesterday. These two make a lot of sense to me. I don't think there's a point in me reviewing them yet. So I'm going to go over cloning a graph, walls and gates. Then I'll try and do 2 more questions after that, like two more new ones. So I'll try and do rotting orange and then Pacific Atlantic water view, depending on how difficult they are. But anyway, oh yeah, walls and gates. I can't even do this on the actual website because don't look. Anyway, yeah, this question makes it makes sense to me. I think when I was going over this question, my solution that I came up with myself, I knew that we had to use BFS, right? But where I got confused is I didn't realize that you had to iterate through the grid first, like before running BFS, to gather where all the cells that are equal to 0 are. Like where all the gates. Because you have to get all the gates, and then you have to start your BFS from the gates. I didn't think about that. So, like, I don't know. I think just logically that makes the most sense to me. And it makes having to do the question over again just makes it pretty easy. Like, all I'm gonna do, save the row and columns so I can use it in the future, right? I like to have a visited set, even though I don't think you really need it for this question. Visited, if I could just spell. I'm going to loop through for R in range row, for C in range column. I'm gonna check if, what the hell? If grid R C equals, bro, there will be so many problems where I won't even read. Bro, there was a few graph problems where I did not check whether or not the grid is full of strings or integers. And there would be times where I'd have like if statements like this, and my code wouldn't work, and I'd spend like 15 minutes trying to figure out what was wrong, and then it was literally just because I would have it as like a string when it was actually an integer. Like it was so bad, bro. That's how I know I need to take a break. Oh yeah, I need to have a queue. All I'm gonna do is I'm going to add visited, add that dot append RC. Yeah, I'm gonna have to do those two. Then, I mean, going to have to do BFS. Well, what am I doing area? It's not area. We have to keep track of what? Distance, right? Distance from the gate. I have that as 0. Well, Q. Then what am I gonna do? I'm going to L equals Q dot pop. And since it is a Q, we're gonna pop from the like first element from the bottom, or from like the left. I like to have directions, so it's gonna be 0, 1, 1. Oh shit, 1, 0. This is just to get the children. The children nodes. 0 plus 1 4 rows, direction columns, and directions. I like to just add everything here. TR plus row DC plus column. Then for me, you can also do this like with using recursion and just make it like recursive calls. Can you? I think you can. I always prefer iterative approaches though, for some reason. It just makes more sense to me naturally. DFS, like, recursive DFS makes sense to me too, but I don't know. Most of the times I think what it is I'm able to, it's easier for me to identify, like to troubleshoot and debug my code when we're working iteratively. For some reason, when I do like recursive functions, it's so hard for me to debug. Probably need to work on that too. But anyway, I can't see. Okay. If so we can add the children. Well, let's do this. If R in range row, and if C in range column, and what else? RC not in visited, and we're gonna need to, it has to be equal to, because we're only changing the cells that have this right here. I'm actually gonna add that in. What is it? 31 plus 1. Okay. If and grid R C I think also I think this should work. Okay. See me, bro. I remember the first time I tried to do this problem. I thought if I just have, like, if I increment distance plus equal 1, in my mind, this was like every time we pass like a level. But I think the issue with this is that the children were adding, like, they're not all like it doesn't work because of how we're adding the children. So because, how can I even explain this? Because we're going from gates, I think what would happen is that like it wasn't consistent. So some nodes might be like 1 away here, but like 2 away from like another gate, and it would just mess everything up. So you can't increment it like this. I'm trying to remember how I did it. I think I did because you can go by the grid our, like, that we're looking at now equals grid that we popped plus 1. Pretty sure this is what I did. This might not work. I might have to add, I don't know. We'll see. Hey, look at that. Boom. I hate, like, I'm forced to use Leetcode's sandbox because this is a Leetcode premium question, which I do not have. Like, how much is it? How much is Leetcode premium? $35 a month. I've heard that it's actually worth it, but I think the biggest thing with Leetcode Premium, like the most enticing thing, is the debugger. I think that would help me so much. And then also just, yeah, questions by company, I think would be very helpful. I don't know, if I was working, like if I was working full time, I would do this. I would like get Leetcode Premium. But yeah. Oh, what did I just do? Okay. Okay, this is not what I did. I did walls and gates. And this is gonna be the second time I did it. I think that's pretty simple. Graphs, medium. And today is the 9th. I hope this all pays off, bro. I hope all the grinding I'm doing now pays off eventually. I really do. I think that's one of my fears. It's like I'm doing all this, and then it's like I'm still messing up, you know? Clone graph 3. Let's do this question right here. This question is really easy. I didn't think, like, this, honestly, I know it is a graph question, But I feel like those are pretty much just using like a dictionary. Like that's the main data structure. Not we're not really doing anything. I feel like I don't know. I think another thing I need to work on is rereading the questions when I'm like when it's my second time approaching a problem, just rereading the question instead of just like going in and trying to like I remember what the question is about, but I think it's good to just develop another to look at it again, maybe develop like another way of approaching this problem. Given a reference of a node in a connected undirected graph, return a deep copy of the graph. Each node in the graph contains a value int and a list of nodes of neighbors. So each node's value is the same as the node's index. Value equals 1 second, with value equals 2, and so on. The graph is represented in the test case using an adjacency list. I need to get better at working with graphs in adjacency lists because I don't really have that much experience other than this problem.
The French green.
The odds are very high that.
I do not.
Yeah, man. Okay. Your node will always be the first node with value equals to 1. I think my favorite section out of all Leetcode problems, I think it might be linked list. I love linked list questions for some reason. I think they're just like, I think they're pretty fun. I think it's linked lists and graphs so far. I think graphs have the most like creative questions. My least favorite is definitely, I don't like backtracking, but I like graphs. My least favorite is probably like stack. Trees are okay. Like I don't really like heaps. I don't think heap questions are too bad though. I'm saving all of the majority of like hard questions, right? I'm saving them for like once I finish all of this, I'm going to go back and go through the 150 again. But I think since I've done every problem, I expect it to take me way faster. Like I think I'll be able to go through like arrays and hashing in a day. 2 pointers, I could do that in a day. Stack a day, you know what I mean? So it's probably only going to take me like a week and a half to just go through all 150 problems again. Even backtracking, like I know since I've seen these questions, I'll be able to solve them on like maybe like 1 or 2 attempts. I'm not gonna like really, yeah, you know what I mean? Like I expect myself to just go through everything really fast. Like right now I'm spending a lot of time just like understanding a solution. So all right, let me do this question though. Yeah, I mean, one, like 2, 2, 4, right? Because 1 is connected to 2 and 4. Node index to 1 and 3 to 2 and 4. 4 is connected to 1, 3. All right, yeah. So just gonna need a dictionary, and the approach to this problem is to create a dictionary where the key is the node, and then the value is like the new node that we create. That's like the same. And I remember this problem is very similar to there's a linked list question I did. I think it might be copy list with random pointer. You know, it's like yeah, I think it was like this. It reminded me a lot of that because I use the same technique in both questions. So do lookup. Create a method because what were you doing? Basically what we're going to do is we're going to check if the node is in the dictionary. We have to just like if we look up the node in the dictionary, like it already has a copy created, and we're just going to return that copy. But if not, then what we're gonna have to do, I think we're gonna have to create like we have to do like make a temp. It's going to equal node of like we have to have the same value, right? And then we want our and then we want our we want the lookup of node is going to equal temp. Yeah. Now what we have to do, we have to look for n for like the neighbors in node dot neighbors. Basically, what are we gonna do? We're gonna append. We're gonna create the neighbors for our temp variable. Temp dot neighbors dot append, and then we want to recursively do this. So we're just gonna, because it's just gonna add all, yeah, just by doing this, it's gonna add all the neighbors there. What else? What do we want us to return? Do we have to return everything? Anything? Oh, we don't have to return anything. think we do have to return like the actual. Here. Okay, and then what do we have to do? I think we just have to return. Yeah. We have to make sure if node else none. Because I remember that did give us an error. I forget the H. Neighbors. Let me look at my streak, bro. I can't believe, bro. I swear I coded on the 3rd. I think I just didn't submit. My dumb ass, bro. 349 submissions in the past year. That's it. I feel like I submitted way more. But anyway. Bro, I was going in May. Right? I was going crazy in May. What, like, this day, after the 28th, I was presenting my thesis, like, in the next month. So I had to just, like, relax a little bit. But even in June, I was going crazy, and then, like, you can see, I think my thesis was, like, when did I present it? It was, like, the 28th, I think. Yeah, it was, like, this day. So I had to just grind, bro, this whole week. And I was like, let me get back into it. So my goal is to do a problem every day for, like, a month. But anyway, rotting oranges. Let's see what that hoopla is about. I feel like graph questions make the most sense too, because I don't know, I find myself being able to kind of like think through them the easiest. Or given an n by n grid, where each cell can have one of 3 values, 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So I think this is a BFS question too, because we can do this the same way that we did the last question, where we think about like each level and like incrementing a value at each level, right? Because the adjacent nodes, it's like boom, then the ones adjacent to this one, it's like boom, boom, yeah. So but we only care if the cell is fresh or rotten. And I think what we want to do is we want to go through the whole grid, find where there is a rotten orange. Yeah, we have to find where there's a rotten orange. In this case, it starts with 1, but I think you can start with like probably like 3. And then okay, here's what I'm thinking. Ready? So we first, before we even do any BFS, we go through the grid. We find the locations of all the rotten oranges, right? We're gonna run BFS on each of those locations, and then we're gonna just have the minimum. You know what I mean? Yeah. Yeah, so this is essentially what I was even thinking. Is it multiple though? Are we saying that it's one or multiple oranges to start? I think we are to assume that it can be multiple. Because any one, it can be 0, 1, or 2, yeah. So I think what we're gonna do I'm debating, should we keep okay. Equals 2? What's the rhyme? 2. I think we should have visited. Ryan dot append see visited and our see right, and then once we do that, I think we should create a function so that we can, because we're gonna have to do BFS multiple times. Or do we even need to? I'm gonna create a function. Bro, one thing I never used to make functions within a function. I used to always just like make it outside. And I didn't realize like the reason people do this is so you don't have to pass in all of like the grid and everything. I was like, damn, why haven't I been doing that? But so we have the queue. Look at while queue. Want to pop off. Okay, do this. It's going to be 0, 1, 1, 0. It's 1, 0. We're gonna do get the children. Row. Now we gotta check that if R in range row and C in range column. And what else? What are the conditions that we want to add to our queue? And we'll gotta make sure RC not in visited. And let's do SB. And it has to be a fresh orange, right? And grid of R C equals 1. So I think those are the conditions that we want to add a fresh orange. I mean, that we want to add child node. But I wonder, like, do I want to keep do I want to keep I feel like I might want to use a different visited each time, because I want each time I run BFS I want to add. I think we want to, cause like let's say we start here. Like let's say there's two um, rotten oranges. Oh my god, bro. My dog just barking. Yeah, but say that there's a rotten orange here and then a rotten orange here, right? I want to run BFS here, and then it's going to add all the visited nodes eventually, right? But when I run it here, I don't want there to be any like um, any boxes marked as any oranges marked as visited. So I think I want to keep like the visited in the function so that it resets every time. You know what I mean? So I think I'm going to have new visit equal to visited, right? Should I make a copy? Can I make a copy of? Can you make a copy of a Okay, yeah, it does. I need to know a better way of like incrementing the distance value by one, like for each level, because I feel like this. We'll see if this works. We'll see if this works. I think this should work actually. Hold on. Right. Okay. think what we're gonna want to do is for row I mean, because I need to increment through. Should I have it be a set? I might make it a set. I guess we don't even need the raw in list. I'm gonna check if R C and visited, right? Because these are rotten apples. I mean rotten oranges. I think it should be something like this. Actually, we want min, right? Not the max. Ew. That's equal. Can I do like float infinity? Return. I don't know if I can do the float infinity. Oh, if it's not possible. Let's see. Well, I tried. I feel like my logic is right though. I think just the way I'm executing it is probably wrong. Streaming for an hour. Like, I know it's BFS. I know that. Should I try and fix it? I feel like I've spent 15, 20 minutes on this. I don't really want to. I forgot this case. Rotting oranges.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's
feel like this
solve
question
the
isn't
problem
even that
rotting
bad.
oranges. We're given an m by n grid where each cell could have 3 different values. It could have a 0, which represents empty. It could have a 1, which represents a fresh orange, or it could be a 2, which represents a rotten orange. Every minute that passes, any fresh orange that is 4 directionally adjacent, meaning either up, down, left, or right. So if it's right next to a rotten orange, then that fresh orange will also become rotten. We want to return the minimum number of minutes that must elapse until no fresh orange exists. But it might be impossible, suppose if a fresh orange was actually not next to any other oranges at all, including any rotten oranges, then that fresh orange would never become rotten. So if it's not possible, then we can return -1, but if it is possible, we return the minimum number of minutes that it takes. So you can see in this example, which is actually a very simple one, because we are only given a single rotten orange, but we could be given multiple rotten oranges. But in this case, we see that this is the rotten orange, right? Right now we're at time equals 0. And let's say 1 unit of time passes, now we're at time equals 1. What happened? Well, the adjacent oranges to the rotten one also became rotten. So this is rotten now, and this is rotten now. Okay, now another unit of time passes, it's time equals 2. What happened? Well, all the other oranges which were adjacent to rotten oranges, like these two, also became rotten. Okay, now we're at time equals 3. What happened? Well, this orange, which is adjacent to a rotten orange, also became rotten. Now we're at time equals 4, and this last orange also became rotten because it's next to a rotten orange. So at time equals 4 minutes later, all oranges are rotten. So we return 4. That's exactly what they expect in this example. Let's say this is the grid that we were given, and these orange things are the oranges. And let's say these two initially were rotten. What kind of algorithm can we do to make sure that the adjacent oranges also become rotten, and then track the time that it takes for each layer to become rotten? Well, you could try a DFS, right? That's like the first graph algorithm that most people try. In this case, it's not really going to work. We run a DFS, let's say, on just one of the rotten oranges. Let's say we pick this one first. Okay, we run a DFS on the adjacent spots. Okay, here's an adjacent spot, so this becomes rotten, this becomes rotten, that's time equals 2, then this becomes rotten at time equals 3, then these two become rotten at time equals 4, and then lastly this one. But that doesn't really work because it took us 5 units of time to make these rotten. But that's not actually what's going to happen, right? These two initial rotten oranges are simultaneously going to be making the adjacent oranges rotten, right? Like after 1 unit of time, this orange is going to become rotten from from this one, and this one is going to become rotten from this one. After another unit of time, this is going to become rotten from this one, and this is going to become rotten from this one, and this is going to become rotten from this one as well. After 2 units of time. After 3 units of time, this last one is going to become rotten either from the one above it or from the one to the right of it. So in 3 units of time, all of the oranges became rotten. But we didn't use DFS. If you were watching carefully, you might have noticed that the main algorithm we didn't use, so it's going to become rotten. Orange is going to become rotten from this one, and this one is going to become rotten from this one. After another unit of time, this is going to become rotten from this one, and this is going to become rotten from this one, and this is going to become rotten from this one as well. After 2 units of time. After 3 units of time, this last one is going to become rotten either from the one above it or from the one to the right of it. So in 3 units of time, all of the oranges became rotten. But we didn't use DFS. If you were watching carefully, you might have noticed that the main algorithm we were actually using is BFS, breadth first search, right? Which is also a standard algorithm. And the reason it's helpful for us is because we don't have to finish running DFS on a single rotten.
Okay, I was thinking of it this way, where I was like starting here, then we go through. Yeah, bro. So I think what we can do. I think I can get rid of this, right? So I think it should always find the minimum distance. Why is this not?
orange. We can run the BFS algorithm simultaneously on multiple sources at the same time. So basically what we're doing is running multi-source BFS. And usually BFS is implemented with a queue data structure. So basically what we're going to be doing is initializing our queue with the initial rotten oranges. We're going to pop through every initial rotten orange, and then we're going to call that 1 unit of time.
Good.
And then to our queue, we're going to add the next rotten oranges. So these two would not be in our queue anymore, but this one over here this one over here would then be added to our queue. And then we're going to pop through those ones as well, and then call it our second unit of time, and then keep going like that. But how do we know when we're actually finished? Well, once our queue is empty, then of course we can stop. But it's not guaranteed that we will actually have made every single orange rotten. Suppose there was an orange all the way over here that's a fresh orange. It's not rotten yet. Of course, we know that these oranges are going to become rotten, but this is not going to become rotten. So basically, after our queue is completely popped, what we're going to notice is there is a fresh orange remaining. And the way we're going to know about that is because we should keep track of how many fresh oranges there are initially, right? In our case, I think there's about 7 fresh oranges, right? And then by the time our BFS algorithm is done, we're down to 1 fresh orange. Because we still have a positive number of fresh oranges, that means we were not able to make every orange rotten, and therefore we're going to have to return -1 as our result. But if we were able to do that, right? Let's say this orange didn't exist. We, make all these oranges rotten, then we keep track of how much time did it take us to make all of the oranges rotten. It was 3 units of time, I think. So then we're going to return 3. So that's the overall algorithm. As you can kind of tell from the BFS, it's multi-sourced, but we're still only going to be visiting each orange, each cell in our grid at most once. So we can say that the time complexity is going to be n times m, where these are the dimensions of the grid. And I think in the worst case that the memory complexity is also going to be the same, because we're going to be using a queue and all that. So that's enough for us to get into the code. So let's do that now. Okay, so now let's code it up. So the first thing we're going to do is initialize our deck. It's going to be empty init path, and you get the entire grid. Some nested fresh oranges represents orange in the first place. Rotting append we're doing is says if our cube either of those are true, then we're going to continue the loop. So now we have a certain number of rotten oranges in our queue, and we want to actually pop every single one of them. So basically we're going to create another loop while let's say we have 3 oranges in our queue, then we're going to iterate through the loop 3 times. We're going to pop those 3 oranges, but at the same time, we're actually going to be adding the adjacent oranges to that queue as well. Our times from the queue one is in our loop, and it's basically the 4 directions that we could move in. So it's going to be pairs, let's say 0, 1.
I just start doing it this way for iron.
And 0, -1, and 1, 0, and -1, 0. So these are the 4 directions we could move in. So that's what DRDC is going to represent. So let's actually calculate what the row would be. So initially we're starting at RC, and then the adjacent spot that we're looking at is going to be DR plus R and DC plus C. So this is one of the 4 adjacent spots, row column. And what we want to do with this position is make sure that it's in bounds and that it's a non-row and it's a fresh. What we're doing here is checking that the row, basically if the row is out of bounds, if it's less than 0, or if it's too big, or if the column is out of bounds or it's too big, or the grid cell is actually not a fresh orange. If any of these are true, we're going to continue to the next iteration of the loop, because that means this is either out of bounds or it's not a fresh. Also want to add that position to our queue, so that row column pair, so that over the next iteration of the while loop that we can include that, right? Even though we're appending to the queue, this portion of the for loop isn't going to change, right? That length was a snapshot. We're not going to continuously update that. And last but not least, make sure to decrement the number of fresh oranges, because that's one of the indicators of if we can stop the algorithm or not. And remember, this loop was going through all of the rotten oranges, and then the adjacent fresh oranges were being set to rotten as well. So that actually happened in 1 unit of time. So after that loop is done executing, we can increment our time by 1. After this loop is finished, then it's time to return our result. But how do we know if we can return the time or if we have to return -1? Well, we can return the time if fresh is equal to 0. That means we made every single orange rotten. But else, if it's not, then we have to return -1. That means there's some oranges that we just can't make rotten. Okay, so that's the whole code. Now, lastly, let's just run it to make sure that it works.
Is this even BFF? Like, popping from the right. That solution's cool, but I don't know. I think the way I would do it is I would iterate through. Right, I'd iterate through. Add the rotten. Then again. That time. This should, yeah, let me just make this time. I don't confuse myself. Like, I don't even think we need this visited, to be honest. Yeah, I really don't, because just get rid of this. Because what I'm thinking is, okay, we do this, boom, grid equals we queue this there, and then we set grid of R C equal to 2, and then okay, I do need to do this. And then I think that like so the way that I would do it, right, is I'd probably do this. And I think about this. I think about my approaches and how I would naturally think doing this problem. Like if I got asked this in an interview, my instinct is going to be to do it this way. Is I know I'm probably going to be under pressure, so I probably will just go like this. Go through the where I do this, right? And if return time if fresh, not 0, else -1. Time if else after if. What? If grid RC equals 1. What? Well, Q. Q dot append RC grid. I feel like this should work. Length Q. And grid, row, column. Q dot append. Have to be outside. has to be within the while loop. Then not. Oh, this is still in the for loop. I'm done. Okay. Try this. What? I don't get why this is not working. In my mind, this should work. Because I'm appending all of the rotten oranges to the queue. Then I'm going through the queue. Right? Running BFS. If R in range, let's see, grid equal to 1. Yeah, if it's fresh. Setting it equal to 2, and then like, I don't think this would even change anything. Turn time. Oh. Oh, whoops. Equal to 0. Else return. Because there shouldn't be any fresh. I don't know. I don't know what I'm doing wrong. maybe we need this variable right here. Maybe we actually do need to do it this way. Because I guess there's situations where the Q, like, when it's not possible to make all of the oranges Ryan, the Q could still be full, like could still have elements in it. I think that's what the issue is. Because there's a case where the Q could still have elements in it, and but it's impossible to make all of the oranges Ryan. So I guess, like, I don't know. I'll come back to this tomorrow and try and think of another way. I need to keep track of the fresh. Maybe do I really have to do it with do I have to do it DFS? Do this problem DFS. Okay, so that doesn't matter. Turn time if fresh is equal to 0. What am I doing wrong? It shouldn't even matter if I don't know what I'm doing wrong. Why is it printing out 1? -1. Oh my gosh, I'm stupid, bro. I'm so stupid, bro. Wow. This is literally the issue. This is literally the issue. What? Am I tweaking? Am I tweaking?
And actually, I just noticed I made a couple of little mistakes. So over here on this line, I forgot one of the OR statements. So let's add that as well. And actually, here we have queue.pop. But remember, we're actually adding to the queue. When we append, we're adding to the right side of the queue. So when we pop from the queue, we want to make sure we're popping from the left because we want to pop, the more recently added oranges, right? That's why we're taking this length. If the length was 3, we would want to pop the 3 oranges from the left side, not the same oranges that we're adding to the queue. So make sure that this is a pop left. So with that being said, let's run the code. To make sure that it works. And as you can see on the left, yes, it does.
Why is my code not working? I'm actually about to lose my mind. Fresh plus equals 1. Q.append. Okay. While Q and fresh greater than 0. Been an hour and 40 minutes. I've been on this problem for probably like 45. Bro. Oh my god, I gotta pop it in here. Okay, that's the issue. I gotta pop it inside the for loop here. And not out there. Oh my god. Like, damn, bro. I think I'm just gonna stop there though. Rotting oranges. What else? I think I'm gonna stop there. There's other things I want to do. Let me look at this problem though. I'm not gonna do it, but okay. So dealing with an adjacency list. All right. Well, how many more graph problems do I have? I have 1, 2, 3, 4, 5, 6, 7. 16 submissions. I don't know what the fuck I'm doing. All right. I'll call it there. Thank you guys for tuning in. I'll probably stream again either later this week, maybe next week. I don't stream every time I Leetcode anymore. At first, I was streaming like every single day that I like Leetcoded. But sometimes I just feel like listening to music or like just listening to like a YouTube video, like a podcast or something while I Leetcode. So, yeah. Thanks. How do I stop this?